Greetings. Welcome to physics, not physics, well, the physics unit within physical science. We just took up two questions. You can pause the video if you want to take a look at those. Just slowly scroll. These questions from earlier in the week. I'm just pausing, see if you want to look it up. They're on video. There you go. But right now, I'll give you guys a handout about the pinhole camera. So pinhole camera, it's a demonstration, and we're going to play around with them. I got three, and then I have a demonstration box too. Okay, this demonstrates, we've been talking about light with wave properties, and it has particle properties. So the pinhole camera demonstrates the particle nature of light. Now I'm going to use a flame right away, and a pinhole camera. This is the side view of the box, and I'll just pause the video and we'll turn out the lights, and here's how the image is formed. The only way it can pass through this pinhole is light from the top has to pass through the pinhole, right? Light from the bottom of the flame pass through the pinhole. Does this make sense? It's the only way. Light from the middle too, but I'm not. It gets messy if I start like light from everywhere goes through the pinhole. I'm not drawing a straight line. Every point has to pass through this pinhole, right? You're going to draw the green line. So what happens is light from the top, etc. It forms this picture of the candle. Okay. I have that there just for the disappearing box. Does that make sense why light is upside down? Because the light from the bottom of the image passed through the pinhole, and that's the only way it can go. And then draw yourself a flame that's upside down. I only put the candle wick here so you can definitely tell it was the upside down. Now, what the term we use is inverted image. Invert, upside down. Image, I think, makes sense, is what we call it. This is a real image. You might want to underline real because it can be projected onto the screen. In physics, say something's a real image, it could be projected on the screen. A virtual image, when you look in a plane mirror in your bathroom, not the curved one to make it plane mirror, you get it right side up. It's not upside down. And if you take a sheet of paper beside you, you'll never get the image of your face projected on it. It's not real. It's called a virtual image. And light travels in straight lines. Okay. One other thing. We've got a way to come up with how to calculate how large these things are. So it depends on the size of your pinhole camera. We're going to slide. We've got this HI over HO, the height of the image over the height of the object, is equal to the negative distance to the image. What's that? From, did you get those? What's that? Yeah, but we handed them out, and did you get that? Did you pick those up? Okay, that's where they are. That's what I'm saying. Okay. The bulletin board by the tap. Now, the calculations are pretty easy. We're going to just try this. 70-centimeter tall object. That's the height of the object. It's placed. So this is the height of the object. It's placed 4 meters from a pinhole. That's the distance to the object. The screen is what forms the image. It's on the inside of the box. That is the distance to the image. This one. What is the height of the image you're going to get on the box in the camera? Pinhole. So we got 3 of the 4 variables. On the other side, not I'll talk to you. Negative sign just means it's going to be upside down. This is plug in the numbers. H up. That's what we want. H up. Replace with 77. Distance to the image. 30 centimeters. The negative sign. And finally, wait a minute. I don't have the same units. I have meters. And how many meters and centimeters? How do you go back and forth? What is it? How many years in a century? How many cents in a dollar? 100. So how many centimeters to a meter? 100, right? So that's 400 centimeters. Okay. Mathematically, what do I do to solve this? Multiply up to 70 to get to each one. Negative sign, 30, 70. Okay. And then I'm going to just put it in my calculator. We'll have to do this one. I get 5.25 cents. That's the negative sign. The negative sign just means that it's upside down. It doesn't mean that it's necessarily small. I'm going to stop